Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The viscous clutch in the cooling system of the car engine is used as an alternative to the electric fan. Let's consider how the fan viscous coupling works, its device, possible malfunctions, advantages and disadvantages. The role of the fan viscoil in the internal combustion engine cooling system. The fan with a viscous coupling is installed on cars with a longitudinal arrangement of the engine, usually all-wheel drive and rear-wheel drive models. In this arrangement, the radiator fan pulley is most appropriately connected to the pulley of the water pump. As you know, the rotation of the water pump is transmitted to the water pump by the service belt from the crankshaft pulley. The disadvantage of such a design is that the fan impeller speed will always be proportional to the crankshaft speed. Such a device will cause the engine to be excessively cooled at high RPM in cold air conditions. And this will reduce its efficiency. In addition, the permanent connection of the impeller and crankshaft pulley will increase mechanical friction losses, which will take away power and increase fuel consumption. The fan Viscoflex allows you to adjust the speed of rotation of the impeller depending on the temperature of the engine. The shaft with the connecting flange is attached to the cooling pump drive. Therefore, its rotational speed is always proportional to the crankshaft revolutions. The shaft in turn is attached to the drive pulley, which rotates in the working chamber. The working and reserve chambers are separated by plates. The transition between the chambers is only possible via inlet valves and return ducts. The reserve chamber is initially filled with special silicone oil. The drive pulley, or disc as it is also called, has oblique teeth on the circumference. These teeth allow the oil to flow back into the reserve chamber when rotating. The surface of the drive discs, as well as the dividing plates, has special ribs. They turn the working chamber into a kind of labyrinth network through which the silicone oil circulates. The coupling housing, to which the fan impeller is attached, is connected to the shaft, rotor of the Viscoflex, by a conventional ball bearing. The inlet valves are connected to a bimetallic plate, which is located in the front of the clutch housing. When heated, the plate expands, which increases the valve cross-section. Properties of silicone oil. The main feature of the silicone fluid used in fan Viscoflexes is heat resistance and viscosity stability. As the temperature changes, the oil changes its viscosity only slightly. Some sources state that the oil expands as the temperature rises. This causes viscous engagement of the drive disc with the clutch housing. Such understanding of the principle of operation of the cooling fan visco clutch is false and has arisen, most likely, due to the comparison of the fan visco clutch with viscous clutches of transfer cases of four-wheel drive cars. Differential viscous clutches utilize a dilatant fluid whose viscosity is highly dependent on the rate of shear strain. Principle of operation of fan viscous clutch. When the working chamber is not filled with oil, the drive disc rotates freely in the working chamber. A small amount of oil is still present, but the coefficient of adhesion of the drive pulley with the body of the Viscoflex is minimal. So with an increase in engine speed, the speed of rotation of the impeller does not increase. The process of engine warming up and increasing the temperature of the fuel in the radiator is accompanied by heating of the bimetallic plate. Heating up, the plate expands, which leads to the opening of the inlet valve and an increase in the amount of working fluid flowing from the reserve to the working chamber. The friction arising between the drive disc and the separating plates leads to an increase in the rotation speed of the fan casing and impeller. Principle of operation of the fan Viscofluid. Decrease in the temperature of the rushing air leads to a gradual return of the bimetallic plate to the initial position. Accordingly, the inlet valve passage cross-section decreases, the liquid is distilled into the reserve cavity. Reducing the clutch coefficient leads to an increase in the speed difference between the drive shaft of the Viscoflex and the housing. The fan impeller slows down. Operation of Toyota Viscoflex. On the example of specific temperature regimes, the device of Toyota fan Viscoflexes assumes the presence of two working chambers. In the first versions of the design there was only one chamber. Bimetallic plate in the cold state. Plate is heated by warm air. The inlet valve of the front chamber is open. Coefficient of thermal expansion corresponds to the maximum cooling mode. The rear chamber valve is open. Why the viscoil rotates on cold? Many owners of cars with a mechanically driven cooling system fan have probably noticed that after starting a cold engine, the fan spins at high speed. Some time after the engine warms up, the number of impeller revolutions decreases. Therefore, it may seem that such a phenomenon is in conflict with the above-described principle of operation of the fan viscous coupling. This effect is due to the fact that during idle time the oil flows by gravity into the lower working chamber. Therefore, immediately after startup, the impeller and the clutch housing will rotate until the oil is pumped back into the reserve section. Installation of viscofluid in the cooling system allows you to reduce the load on the generator and also reduce the cost of the car, excluding the cost of the electric drive impeller wiring. What are the disadvantages of the fan viscoil? Many people complain about the unreliability of the clutch, forgetting that a system with an electric fan also needs repair from time to time. The most common failure is the leakage of working fluid. Despite the fact that most viscous-type clutches are not disassembled, there are proven technologies for restoring the performance of the system. In the event of wear, the bearing is also repairable. That is why it is important to know the ways to check and repair the viscomuff of the radiator fan. Related articles, discussion. Having bought a was and faced with long warming up in winter and almost overheating in the heat in a traffic jam, I started to understand how this device really works. Here is what is finally noticed. When starting the engine, the fan spins at full speed until the first operation of the thermostat. After the radiator cools down to a certain temperature, the whisk starts to slip, the airflow decreases and there is a kind of buzzing sound. At the next opening of the thermostat, the viscera turns on again and everything repeats. Viscous starts to work as it should. When getting in the heat in a traffic jam, the engine starts to warm up and having heated up about 90 to 93 degrees, the viscera starts to slip and the temperature creeps up. Having opened the engine hood and having switched on the heater was able to stop the temperature growth in the area of 97 degrees. The traffic jam moved and the temperature came back to normal very quickly. As a result of these cases, made for myself conclusions about the disadvantages of viscofluid: 1. Long warming up in winter. 2. Poor cooling in the heat at idle engine speed. For myself, decided to get rid of the viscomuff and install L fans. Advantages of which: 1. Faster warming up in winter. 2. Better cooling in the heat, as the speed of the L fan does not depend on engine speed. In conclusion, the principle of operation of the fan viscofluid highlights the fascinating interplay between fluid dynamics and mechanical engineering. By utilizing the unique properties of viscoelastic fluids, these fans achieve enhanced efficiency and adaptability in various applications. Understanding this technology not only sheds light on innovative design approaches but also opens up new possibilities for improving energy consumption and performance in numerous industries. Thank you for watching, and we hope you gained valuable insights into the workings of the fan viscofluid.